Basic object-oriented programming. Hello everybody, this is Ben Finkel, and in this nugget we're going to move on from our simple procedural programming into some more structured, some more well-defined programming methodologies, specifically object-oriented programming, which is an incredibly popular methodology for programming. C and C++ and .NET and Java, these are all object-oriented programming languages, and Python is no exception. It's a great structure for organizing your code. So we're going to start off and talk about what is object-oriented programming. Why do we want it, and what is it going to accomplish for us? How is it going to help us as programmers develop better programs? Then we'll go through all of the specifics in Python, how you define and instantiate a class, how you can define member properties on your classes, how you can create member methods or functions inside of your classes, and lastly we're going to take a look at the constructor function, which is the member method that gets executed when you instantiate, when you create a new instance of your class itself. There is so much to go over here. It's really a complex topic. Let's get started and start talking about it right now. Object-oriented programming can be a really difficult concept to get your heads around the first time you take a look at it. I think maybe the best way to approach it, though, is to talk about why we need it in the first place. What problems does traditional procedural programming introduce, and how do we approach those, or how do we address those with an object-oriented programming methodology? So let's talk about this little code sample I'm going to bring up on screen here. And it's really simple, straightforward kind of code. All I do is I define a calculate circumference function, which, does exactly what you think. It calculates the circumference of a circle based on a radius value that's passed into it. So you give it a radius and it returns a value that is the circumference of the circle that is that radius. And then down below that, I define a few different circles, my first, second, and third circle, give them a radius. And then here I actually use that function and print out the result. So, no big deal, right? This ought to work. But there's some challenges here. So this is a traditional procedural program. I've done one thing. I've defined a function. That's pretty good. I've taken out my math function that I know I can reuse over and over and over, and I've turned it into a reusable function. But look I'm defining circles over and over the same way. I'm saying circle, circle, circle. That's pretty bad, right? They're hard-coded in there. If I needed a fourth circle for my program to work, I'm going to have to open up my source code, type in circle 4 name, circle 4 radius, do all that stuff. That's no fun. I might make a typo. Every time my program or my code needs to change a little bit, I'm refactoring all this code. That's not going to work well for me at all. So if you're clever, you might say, well, we could use a collection. We can use a list of items to create our circles, and that's what I've done down here. Exact same thing I was doing above, except now I've got my circles defined inside of this list. In fact, each circle is a list of data values. First circle, 4.2, and then a 0. That's my placeholder for my circumference. And then below that, I do my calculation and my print. But this has its own challenges as well. I mean, first of all, circle 0, 2, that's not really clear, right? From a code legibility standpoint, understanding what's going on, we don't really know what that is. I know that I wrote it. I intend for that to be the circumference. But hey, it could really be anything. I can store any value in there, and it's not doing me any good. What I'd really like to do is find a way to sort of marry these two options and introduce some new features, some new functionality that allows me to create circle objects that I can manipulate and pass around and hand off to different pieces of my code as needed. And that's the basic idea behind object-oriented programming. Object-oriented programming offers a lot of features that are going to make your programs really, really powerful. For starters, they encourage good code reuse. Like the calculate circumference function I showed on the left-hand side, reusing code is really important. I don't want to write that function 3 times to calculate the circumference 3 times. It's the same every time. I should write it once and reuse it over and over. Object-oriented programming is also going to encourage proper separation of code. You'll hear this a lot, and also isolation of behavior. And the reason this is good is not only because it allows your code to be tested easier, but it also makes your code more legible and easier to read. You'll see that when we start writing some object-oriented code here. Lastly, object-oriented programming is exceptional for modeling data. Now, we haven't talked about modeling data yet, but it's really important in most modern programs to, hey, figure out how you're going to store and manipulate and work with any data that gets sent to your program. Here I've hard-coded my 3 circles into my program, but chances are those circles are going to be input maybe by the user, or maybe I'm going to read them out of a file or a database. There could be hundreds of circles that I need to load up into my program, calculate the circumference of each one, and then write those circumferences back out into a file somewhere. So I need some real help in organizing my code and allowing it to do this, and object-oriented programming is going to be the answer. Now, we're going to start with our approach to object-oriented programming by dialing way back to one of the first concepts that you learn about with any programming, and that's data types. It's really important to understand what data types are, particularly with respect to variables. Let's take a look at that now. So in Python, recall that variables have data types, right? If you say x equals Ben, intrinsically what's happened here inside of a Python statement is the variable x just got created, and because I assigned a string value to it, x is now a string data type, and that influences what I can and can't do with it inside of the Python programming language. I can't now say x equals x plus 5 because it doesn't make any sense to add 5, a number, to a string Ben. What is Ben plus 5? That's confusing. You can say x equals x plus quotes 5, and that'll add the number 5 onto the end of the string, so it will become Ben 5. But that's different than x equals x plus 5, because here, without the quotes, I'm using a numeric value data type, an integer specifically. So these data types are really important, and all the variables we work with can be any number of built-in data types that Python exposes. And this is a pretty comprehensive list of them. There's a few others, but you have integers. You've got long integers, which are only available in 2.x. They're just integers in 3. Floating point values, strings, bytes, tuples, lists, all these things that you work with inside of Python, your variables belong to one and only one of these types. And again, depending on what type it is really going to impact what kind of code you can execute against that variable. So this is a pretty good list of data types, and we enjoy this if we're storing data. But what if we took a more holistic view of our data? For instance, my circles from the previous slide. What if I wanted to store a circle? Well, I did that before by storing the radius of the circle, and mathematically speaking, that's all you really need to know about a circle. But what if my circles I needed to know more about? I needed to know their name, I needed to know their color, I need to know maybe their position on the screen. This is a video game, and I want to keep track of all those circles. Well, we saw a couple different ways I could do that. I could create a whole bunch of variables for every circle, or I could create a list data type and store all the circles inside of that list. But what if there were a way to create a custom data type? So not an integer, not a long, not a float, but a circle data type. What if I could create something that would also be known as an object? This would be pretty handy, right? I could say x equals a new circle, for instance. And I'm just making up some code here. So now x is not a string, it's not an integer, it's something called a circle. But what does that mean? I'd have to define what a circle was, what kind of object, what kind of data type a circle was. And that definition would be called a class. And let's see that actually in action right now. It's going to make a ton more sense when you see it work. But what we are going to do is we are going to define a class for our circle. Then we are going to create a variable that is of the type of that class that we've created. I'm going to start off this program where I define an object the same way. I'm just going to start with defining my calculate circumference function. I like that. I still want that inside of a function, and I still need it available to me. Now the second thing I'm going to do is I'm going to define my circle class, and that's very easy to do. I simply say class, and then I give it a name. I think circle is going to be a pretty appropriate name. The capital C at the beginning of the name circle is tradition. It's kind of a common standard. So generally speaking, you want to name your classes with a capital letter at the beginning. I'm calling this class a circle. And it's not going to do anything just yet. I'm going to write pass in the class definition. Notice the indented notation. So it doesn't do anything. I've simply created something called a circle that I can now reference. And I can reference it by creating a new variable. Let's call circle1. And notice circle1 has a lowercase c. So frequently your variables, which ultimately are going to be instances of a class, begin with a lowercase, but the basic class definition itself begins with an uppercase. So I'll say circle1 equals circle. And there we have it. That's all I need to do. I now have a class defined. It's named circle, and I've created a new instance of that class. I've created a variable called circle1 that is of a type circle. It's not an integer, it's not a string, it is type circle. And that's a really important concept to understand. It's like an integer, it's a variable and it's got a type, but it's not like an integer in that we can't do math against it, right? It's not a string, we can't append text onto it. It's a circle, and at least for right now, that doesn't mean anything other than giving it a name, circle. Now, one of the cool, most basic features of classes, one of the things that we can do is we can give them member properties or values or variables. And in Python, I do that simply by creating it dynamically. I can say circle1, oops, get a focus on my page there, circle1.radius equals 4.2. So, what have I done here? Well, I've taken my variable, circle1, and I've given it a property called radius, and I've assigned that value, or that variable, a value of 4.2. So radius inside of circle1 is a float value. The radius parameter, the radius variable, the radius member property is of a type float, and because of that point, it belongs to circle1. So circle1 now has a dot radius value called 4.2. And anytime we want to reference that radius, we simply reference it with the same notation, circle1.radius. So there I can print out circle1.radius. Let's go ahead and save this and see it run very simply. 4.2, that's all that comes out. So I defined my calculation function, I defined my circle, created a new circle, gave it a member property called radius, and assigned that member property a value of 4.2, and then 4.2 was printed on the screen. Now what I want to stress here is that we did not add radius to our base definition, our base class circle. We added it to the instance circle1. And the way I'm going to show that off is I'm going to come here and I'm going to create a new circle. I'm going to call it circle2. And it also equals a circle. So I'm referencing my basic definition, my circle class. I'm creating a new instance of a circle. Just like when you say x equals 1 and y equals 2, you have two different integers. Well, circle1 and circle2 are two different circles, and circle2 does not have a radius value. I never created it. I never assigned a value to it. So if I try to print it, you can see what's going to happen here when my code runs. 4.2 is going to come out, but then I'm going to get an error, and that error specifically says attribute error, circle instance has no attribute radius. So my circle class doesn't have a radius in it intrinsically. I have to assign that value first. And when you assign it to one instance of a circle, in this case circle1, it is not applied or it is not available on other instances of the circle. So again, if I want it in circle2, I've got to create it. I've got to say circle2.radius equals 3.9, we'll say. Now both of my circles have a radius attribute, and I can run it, and I can get those printed out, and I can see the value specific to each instance of my circle. So at first blush, this may seem a little complex. It doesn't necessarily seem easier or faster or more legible than the basic ways that we were doing it earlier in this nugget, that we were accomplishing this sort of same thing. But let's take a look at kind of a clever way we can use this in order to give us a more efficient code as well as create more legible, readable code and reuse some smart code. And what we're going to do is we are going to build a list of circles. Check it out. Here I'm building up a list of random circles. So take a look at my code and you can see the top portion of my code is exactly the same. I define my circumference calculation, I define my circle. Then what I do is I create an empty list that I call circles. And I've got a loop here. I go a loop of 10, 0 to 10. And in each instance, in each iteration of my loop, I create a new circle. I give it a radius, and I'm using random.uniform to give it a random radius. I don't really care what it is. I just want to have a nice random radius. And then what I want to do is I want to create another property of that circle called c.circumference. And I'm going to calculate the circumference. Although this statement isn't finished, what do I need to do here? I need to calculate the circumference based on c.radius. So check it out. In each loop of this instance, I'm going to create a new circle, give it a random radius, calculate the circumference based on that random radius, and then lastly what I want to do is I want to say circles.append c. So this is going to loop through 10 times, and In each instance, it's going to create a new circle, calculate those values, and then append it on my list of circles. So I very quickly, with just 5 lines of code here, I am populating a list of 10 circles. I can make that 20, 50, 100, however many I wanted. I could fill this right up, and my code wouldn't get any longer. And a couple of important points here. Notice that it's fairly legible code. I can say, all right, C equals a circle. So C is a circle. I can say C.radius is where I'm storing that value. I can say, you know what? I don't have to know a whole lot to guess that that's probably where the radius of the circle is being stored. Same thing with circumference. I named my circles list circles, so it's very clearly a collection or a list of circles itself. Then what I can do is down here I can decide what I want to print out. And in my case, I want to print the radius and the circumference for each circle. So for C in circles, now I'm just looping through however many circles there are. So I can change that number 10 up there again to be 20 or 50 or 100. Both loops are going to update appropriately. So for every circle inside of circles, I can print the radius and the circumference. And notice how I reference these things just with C.radius and C.circumference. And the reason that works is because of my for loop. My for loop is looping through, it's getting to the first circle in my list of circles, it's calling it C, then when it's done, it's looping again and it's getting the second list, or the second circle in the list, and it's calling that one C. So they're always called C. I can really take advantage of the fact that my circles are stored inside of a list, and I can take advantage of the fact that their properties are named intelligently. So once again, looking at this code, C.radius, that's going to print out the radius, and C.circumference is going to print out the circumference. Let's go ahead and save this and run it. And there it is. I've got 10 circles, each with a random radius between 1.1 and 9.5. I just chose some numbers there. And their corresponding circumference. So I've already cleaned up my code a fair amount. I've got really powerful the ability to, in this case, generate circles, but what if I were reading these out of a file? What if I had a file with 500 circle definitions in it, comma-separated values? I could very easily read them in, store them in a list of circle objects, and then calculate the circumference on them and print them out. So that's using class properties, or member properties, as they are known, inside of a class to store values associated with each instance of a class. And remember, a class is just a definition of a data type, kind of like a complex integer, a complex any other data type that you might use. Now let's talk about this calculate circumference function, and let's see how we can clean this up even a little bit more. You might have already guessed this, but the circle definition, the circle class, doesn't have to be blank and empty. We can store stuff inside of that class definition and make it available to every instance of the circle that we create. And what I'm going to store in there is I'm going to store this function called calc circumference. I'm going to move it out of here, and I am going to make it a property, or in this case, a method of the class circle. So notice my indentation here. The calc circumference now belongs to the circle class definition. It's no longer defined in what we call the global scope. It's no longer available to the entire program. It's now a part of the circle class. And just making that change, if we take a look at it here, is actually going to break my code. If I try to run it again, I'm going to get an error when I try to call calc circumference, because right down here inside of my first loop, I reference calc circumference, but that doesn't exist. It's no longer in the scope. Calc circumference is now actually a method or a function on the class circle. And we've actually already seen this in action. Right here in this code we're looking at, actually, even if you didn't realize it, check out random.uniform. So what I've done here is I'm actually calling the uniform function. You can see I'm passing it in 2 values, but that uniform function belongs to random, and random is a built-in library inside of Python that I have imported into an object called random, or into a variable called random lowercase r. So when I want to reference the uniform function, I can't just call uniform. I have to call random.uniform. I have to say, hey, run the uniform function that is defined inside of my random variable. Well, same thing down here with calc circumference. I have to say c.calc circumference because I'm referencing the calc circumference that's inside of my circle, which I have named C. Now this might look like it ought to work. I'm passing in C.radius as the radius property, and in a lot of other programming languages this sort of definition would actually work exactly right, but it's not going to work here, and I want to show you why. When I try to run this code, you'll see, if you read the error message, that calc circumference takes exactly 1 argument and 2 were given. And you might say, all right, well, that doesn't make a lot of sense. I only gave it c.radius. That's the only argument, the only parameter that I passed into that function. Why does it think that there's 2 arguments given? Why does it think there's 2 parameters passed? And the reason is functions like this always get passed as their first parameter a reference to themselves, a reference to their own instance of the class. And traditionally we call this self. We define this as self up here in our function definition. So what I can actually do is then get rid of this, and I can say not radius but self.radius. So now we're getting crazy. Let's make sure we understand what's happening here. We are calling the calc circumference function right here, and unbeknownst to us, an instance of c that's calling it is being passed into that function. Now we're giving that instance a name self inside of the function, and we happen to know that c has a value called radius on it because I just assigned it a moment ago. So I can create this function call with self.radius. I simply say c.calc circumference, and then that function is going to get called and run appropriately. So let's save this, give it a run once more, and see that again my values come out exactly like I expected. And this is great. We now have defined inside of the circle class, inside of a circle object itself, the mechanism or the method that we need in order to calculate the circumference of that exact circle, that instance of the circle. In fact, we can do this with multiple different calculations. We can have many different methods on our class. Say we want to be able to also calculate the diameter of a circle. Well, we simply create a new method definition, a new function definition inside of our class. Notice the indentation is still there. Return the radius times 2, that's what the diameter is, and boom, we've got a calculation for the diameter. Area of a circle, hey, we can do that too. What is the function for area of a circle? I believe it's pi r squared, so we'll say math.pi times self.radius squared. So there you have it, a bunch of different functions associated with a circle, and in particular they're associated with the exact instance of the circle that we're working with at any point in time. When I say c.calc circumference, what circumference am I calculating? I'm calculating the circumference specifically of c. And in fact, you data hounds out there might recognize that we don't need to store another value. We don't need to store the circumference inside of our circle itself. I can get rid of this line entirely. And the reason I can do that is because down here I can say c.calc circumference. Make sure to give it my open and close parens because I'm now referencing a function. That function returns a floating value so I can print it out in my print statement, and that's going to work without storing a second instance of my circumference value. I now have my data very granularized down to just the radius value. That's the only thing that defines my function right here is the radius, and I can get all these different values, all these different properties out of it simply by referencing the functions. So I can put all my functions down here with their open and close parens, and I can print them right out. We'll see this run. And there you have it. Every circle randomly created with a radius, and then I get the corresponding circumference, diameter, and area out of them. I'm storing a minimal amount of information. I'm taking up the least amount of memory possible because the circle only has a radius. That's all I need to actually store in memory. Every time I need one of these values, like a circumference or a diameter, I calculate it on the fly so it's immediately available to me. That means if I update the radius of a circle, if my user changes a circle's radius, I don't have to rerun those functions. The next time those functions are called, they will return an up-to-date value for that particular instance of that particular object. So we're going to finish up by taking a look at one very special version of a member method, and that's called a constructor. Now, like its name hints at, a constructor function is a function that gets executed whenever you create a new instance of your class, whenever you construct that instance. And we've actually been calling it all along here, even though we haven't pointed it out or you haven't realized it. That open and close paren down here on c equals circle, that's a reference to the circle's constructor function. We are calling that constructor function, but we're not passing it in any values. Now, we haven't defined this constructor function, so nothing happens when we do that, but we can define that constructor function if we want, and a lot of times you do. I'll show you why this is such a neat thing to do. I'm going to come up here and I'm going to put it at the top of my class. That's fairly typical behavior. Put your constructor first, and it takes a very specific sort of syntax. It's def two underscores, init, two more underscores, then your open paren for your parameters that you're going to pass in. And just like any other method function, the self is always the first parameter that's passed in. So now I've got a function that is going to get executed whenever I create a new circle. And I can do a lot of different cool things here. One thing that I could do, and this is very popular, I want to make sure that my circles always have a radius property. Remember, if I don't reference the circle.radius property and assign a value to it, it doesn't exist, and that's going to break down the line my calculation functions that depend on or assume that that radius property is available. Well, if I just come up here and I say self.radius equals random uniform 1.19.5, now every time my circle is created, self.radius is being created and it's being assigned a random radius. In fact, that means I can get rid of this guy right here. I just don't need it. Go ahead and save this, and now I've got my circle being created with a random radius every time. This will work as is. No problem, right? I could also pass in the radius. I don't have to do it inside of my function. I could say, you know what? I don't know if it wants to create a random radius, if my user wants to create a random radius, or they want to define the radius themselves. And I could do this. I could say, okay, let's say if radius equals 0, then we'll create a random radius. Else, we will say self.radius equals radius. So what's happening here? Well, I'm allowing the user to pass a radius into the constructor function, and if that radius is 0, it will create a random radius for me. So if I put 0 down here, go ahead and save this, what's going to happen? Well, radius is equal to 0, so it's going to use the random function during the construction, and I'm going to get random radiuses right down the line. But if I want to define the radius, I want to say, you know what, the radius is going to be 5.5. This should create 10 circles with a radius of 5.5, and you can see there they are. So you can use the constructor function to supply values to your object, to your instance of your object, right when it's created, and thus verify or ensure that properties that you want to exist always exist when that object is created. So really this basic class definition right here is really at the root of all object-oriented programming. This is where the power comes from. You can imagine taking this class definition, moving it out into a separate file, and just importing it at the top of your code, just like I've done there, and then you can reference it down here. You can use it as much as you want, however you want, inside of loops. You can use it to load data, etc. You've got a lot of powerful code that looks a little complicated when you look at it holistically, but you can see how it really simplifies this code down here. As you get into more advanced object-oriented programming topics, everything's going to come back to this idea of defining classes and creating instances of those classes inside of your code. And that concludes this nugget on basic object-oriented programming in the Python programming language. Now just to recap, we started off talking about what object-oriented programming is, what problems it's trying to solve, and we looked at a simple but problematic piece of Python code wherein we created a bunch of circles inside of these variables, but it was difficult to maintain, it was difficult to update, and at some points it was difficult to read. So we talked about how we could turn those circles into classes. We defined a new class called a circle. We instantiated that class. We created multiple instances of that class. We gave that class member properties, which in our case was a radius. Every circle has a radius, but it's got its own separate radius. So every instance had its own member property of a radius. Then we took a look at how we could define member methods. We created functions like calculate circumference and calculate area on the circle class definition so that every individual circle instance could calculate its own circumference, calculate its own diameter. Lastly, we talked about the constructor function, which is a built-in function that every class has, even if you don't define it, and you can use that to properly instantiate and create your objects so that they look the way that the rest of your code is expecting them to look. I hope this has been informative for you, and I'd like to thank you for viewing.